Namaskar. Today we shall discuss the scientific heritage of India. This topic is quite wide and we will discuss the first part today. India is known for several things. It is a very large country. It is the seventh largest in area. Russia may be the first one, Canada, USA, China, Brazil, Australia, and then comes India. It is only seventh in terms of the net area, but in terms of the cultivable area, it has a very large percentage of its land is cultivable. It is about 51-52% of the land mass of India is cultivable. And not only cultivable, it is very rich. The Sindhu-Ganga plain is one of the finest, the most fertile plain land in the whole world. When you say Sindhu-Ganga plain, it extends from Attock to Cuttack. In fact, a British traveler made a statement that I could move from Attock to Cuttack without touching a pebble. It's about 200 years ago, he said. It is so fertile, so beautiful a land that I can move from one end of the India to the other end without touching a rock, without touching a pebble. It is so rich. In fact, the Deccan plain also is equally rich. And we know that some of the districts in Andhra Pradesh are so rich that they can supply rice for the rest of India, that kind of richness. And it is protected by the Himalayas on the north. And when you say protection, it is not only protection against enemies, but it is also a source of water for India. Many of the North Indian, I think almost all the North Indian rivers, Ganga, Yamuna, Sindhu, Brahmaputra, all these things originate, and the various tributaries of Ganga originate in the Himalayas and water the whole land throughout the year. It is all sea rivers. Supply water to the land. Therefore, a very rich culture, developed in India over a huge time frame. The Indian culture, if you try to date back, we really do not know when it started, but it is from all the available sources, it indicates that it is at least 10,000 years old. We don't know the time of the Vedas. Vedas started fostering this culture. So the culture is centered around the spiritual paradigm, which we have discussed at length, though other paradigms flourish in India. But what we call as the Hindu culture, it grew around the spiritual paradigm, spiritual philosophy. It developed a social and a political system about which we shall discuss in some future sessions. Very rich in art, architecture, literature, music, dance, all these things are around the spiritual paradigm. Then also mathematics, science and technology. India is known more for spirituality, less for science. However, if you dig in, you will find that Indian scientific heritage is also very rich. This society and this culture together fostered a civilization with huge material wealth. It is a very rich land, very rich people, very creative psyche, and the material wealth that was generated here was so large that it attracted repeated invasions from outside. The spiritual heritage is well known around the Vedas, Upanishads, Bhagavad Gita, the Darshanas, the Puranas, the Itihasa. When I say Itihasa, I am referring to the two major epics, Ramayana and Mahabharata. In India, traditionally, they are known as Itihasa. And of course, Kavya, people like Kalidasa, Bharavi, Magha, etc. And then various languages. We have poets like Pampa, Kumaravyasa, etc. in Kannada. This culture invited and attracted people from outside for its learning, for its spirituality, for its science, for its knowledge systems, for its political and social systems, which were unique and attracted great appreciation from people from outside. So the outlook was very, very confident and inviting. All thoughts, all forms of thoughts were welcome, evaluated and accepted or rejected in India, and numerous streams of thought, that is philosophical thoughts, developed in India. And today our focus will be on the scientific heritage. Under this topic, scientific heritage, we shall discuss all these things. Decimal number system, which is the foundation of many of the scientific developments, astronomy, algebra, geometry, metallurgy, medicine and surgery, botany, physics, and then finally the relation, the approach, the attitude between science and spirituality in India. The point I'm trying to make is that in India, the science and spirituality coexisted without any action. In Europe, when the religion dominated, the science plummeted. And when science progressed, the age of reason, the Renaissance, etc., then the religion receded. And they were at loggerheads. We know the story of Galileo and many others, the persecutions. Such things did not exist in India because the attitude of both spiritual outlook as well as the scientific outlook were complementary. They were not confrontational. They were not confronting each other. The decimal system, of course, we will discuss today. We shall discuss only the first two under the part one, the decimal number system, and as to some extent astronomy, not the complete astronomy. So part one will cover only these two. When you say decimal number system, it is also known as decimal place value system. And I quote Laplace, the great mathematician Laplace, who lived around 1800 in Europe, that he gave tribute to the decimal system as the foremost useful invention. Let me quote Laplace. The ingenious method of expressing every possible number using a set of 10 symbols emerged in India. Its simplicity lies in the way it facilitated calculation and placed arithmetic as the foremost among useful inventions. The importance of this invention is more readily appreciated when one considers that it was beyond the two greatest men of antiquity, Archimedes and Apollonius, the mathematicians of Greek origin, Archimedes and Apollonius. And coming from Laplace, we must admit that it is a great tribute, because Laplace himself was a very great mathematician. Why decimal system? Why this kind of a tribute? Look at the European history and look at the Roman number system. Read this number, and with some difficulty one can read it. It is actually this. Notice how it is written. The last set here is 7, and then earlier to that is 80. C means 100, X means 10, and 20 less than 100 is 80. And M means 1000. C written to the left means 100 less than 1000, that is 900. And M means 1000. And M would occur here as well as here at two places. And this X, that is 10, also may occur in the around the 7. One can write it that way. So this is the Roman number system, a sample of Roman number system. In the place value system, it is simple, 4 digits, 1987, easy to remember, easy to use. Now write something like this, say 2020 if you want to write. Then you will have to write 10 and 10, nothing in between. Then 2000, that is 1000 and 1000. Look at the tedium of this presentation. We are able to write small numbers like 1987 easily, but we just read what is written below. Can you read it? Can you make sense out of it? Yeah. Let me help how to read it. I have bracketed, and can you read this now? I have further split it. Now it shows that it is 1-124-555-3684, which is a telephone number, which we routinely use this kind of numbers today. And it is usable in this form, in the decimal form, but it is not very convenient to use in the Roman system. If you take the decimal system, I want to divide 1987 by 35, say. I have a long division method. I wrote 1987, 35, so 175, 5, all these things we can do. But how would you do that using the Roman number system? Can you write this? Can you write one below the other and subtract? That is the value of place value system. The Roman system did not allow for this facility. And when we represent large numbers, huge numbers, the Indian system, decimal system, allows you for that. But the Roman system, the largest number, conceptual number that they were referring to was the myriad. Myriad means 10,000. And if you want to write, say something like 1 lakh, 10 to the power of 5, see how compact it is in the decimal system and how tedious it is in the Roman system. This is 1 lakh. So what am I saying? I am saying that the decimal place value system allows you to write huge numbers. It allows you to write not only huge numbers, it allows you to write very small numbers as well. That is the meaning of what Pires Laplace tribute gives us. This is another great scientist, Albert Einstein, who gave a tribute saying, we owe a lot to the Indians who taught us how to count, without which no worthwhile scientific discovery could have been made. Now let us look at the antiquity of the decimal system. How old is this system? The concept of zero is an integral part of the decimal number system. And there are many speculations that this concept of zero could be as old as Aryabhata. And some people go a little further and say it is as old as the Baksali manuscripts. Baksali manuscript, Baksali is a place, I think near Chandigarh also, where they found manuscript, ancient manuscripts, which is dated as the 3rd century AD. And there are indications that they have used the decimal number system there. But a more concrete evidence is based on the Aryabhatiya. So this is what the Wikipedia says, that it must be as old as 500 AD. Look at the statement. I have a point to make here. Please look at the statement. The place value system, first seen in the 3rd century Baksali manuscript, was clearly in place in Aryabhata's work. While he did not use a symbol for zero, the French mathematician Georges Ifra argues that knowledge of zero was implicit in Aryabhata's place value system as a placeholder for the powers of 10 with the null coefficients. All this logic to place the number system around 500 AD, 1500 years ago. However, the system, Aryabhata did use the system. This is Aryabhatiya, quoted from Aryabhatiya Ganitapada. The shloka says the numbers Eka, Dasha, Shata, Sahasra, Ayuta, Niyuta, Prayuta, Koti, Arbuda, Vrinda, Mahavrinda, etc. So it is certain that it is around Aryabhata's time. But in reality, it was much older than that. I'll give you support on this. This is Krishna Yajurveda Taittariya Samhita. Iti Krishna Yajurvedi Taittariya Samhitayam Saptamashtake Dvitiya Prapathake Vimsho Anuvakaha. That is same Samhita, 7th chapter, point 220. That is the shloka. Look at the shloka. It quotes the number system which Aryabhatiya had set in 500 AD. It says Shataya Swaha, Sahasraya Swaha, Ayutaya Swaha, Niyutaya, Prayutaya, Arbudaya, Nyarbudaya, Samudra, Madhya, Anta, Parardha. It goes up to Parardha. Parardha is 10 to the power of 12. How old is Yajurveda Samhita? We really do not know. But it is certainly more than 5,000 years old. I will tell you why I make this claim. So the Vedic number system, now I can claim it as Vedic number system. It starts from Shunya, goes up to Dasha. And from Dasha, Vimshati, Trimshati, etc., it will go up to Shata. And from Shata, it will go to Sahasra, Ayuta, Niyuta, Prayuta, Arbuda, Nirbuda, Samudra, Madhya, Anta, Parardha. 10 to the power of 12. Huge number, considering the ancient times. It was a very huge number and was conveniently represented using the decimal system. However, you will see Valmiki's Ramayana. Valmiki uses a number system, represents huge numbers, huge numbers. This is the context in the Yuddha Kanda. That is, Sri Rama and his army had crossed over to Lanka. And in Lanka, they had put their barracks, their camp, and outside the Lanka fort. And from the bastion of the fort, Ravana watches this and he sends his ministers to make an assessment. They go as spies, Mayavis, they enter the camp and make an assessment, come back and make a report. The minister's name is Shuka. Shuka and Sarana are a duo. There are a couple of ministers who make a report to Ravana, and this is the report which Valmiki quotes. And the numbers that he mentions about the size of the army, I have extracted it from the verses and put it here together. He talks about Koti, Shankha, Mahashankha, Vrinda, Mahavrinda, Padma, Mahapadma, Kharva, Mahakharva, Samudra, Ogha, Mahaugha. By that, when he starts, it is Koti, that is 10 to the power of 7. But when he ends up in, it is 10 to the power of 62. So Valmiki's number system does not stop as 10 to the power of 12, but goes to 10 to the power of 62. Mind you, this number is an enormously large number. It is not a practical number. When I say it is not practical, what I mean is that there is actually, the army size was not this large, because 10 to the power of 62 is larger than the number of molecules on this planet Earth. So obviously the army size cannot be larger than the number of molecules, isn't it? Therefore, it is a greatly exaggerated number. Valmiki uses this device, what we call as Upama, which is, quite frequently and quite effectively. He always talks about numbers which are much larger than the reality. He will say, Bhagirath has ruled for 32,000 years. He will say, Sri Rama ruled for 11,000 years. And then he will say, the size of army is 10 to the power of 59 or something like that. 10 to the power of 62 in this case. And then he will say, Vishwamitra did tapasya for 10,000 years. So his numbers, I found that it is very convenient. If you knock off the last 3 zeros in the number, then it makes sense. For example, he will say in the Janaka and Sri Rama and Lakshmana along with Vishwamitra visited Janaka's Mithila, and they desired to see the Shivadhanus. And Janaka ordered that Dhanus be brought to the court. And he says, Dhanus was kept on a box which was pulled by 5,000 people. So knock off the last 3 digits, it could be the realistic number. The device apart, Valmiki was using huge numbers with great abandon. And my point is that a number system was available for him to use. And how old is Valmiki? How old is Ramayana? There is internal evidence in Ramayana which talks, there are several evidences. Because Valmiki was a very good astrologer and he often connects the happening on the ground to the happening on the sky. He's a very good astrologer. At 10 different places he does this. And this one of them is the birth of Sri Ram. He gives a complete birth chart of Sri Ram. Look at this quote. After the completion of the ritual, this is the Putra Kameshti ritual conducted by Dasharatha. 6 seasons have passed by. That is, the 6 Rutus have passed by. The 9th day of Chaitra Masa, Navami Tithi, Punarvasu Nakshatra, for which Aditi is the presiding deity. And when 5 of the 9 planets, Surya, Kuja, Guru, Shukra, Shani, are in ascension in their respective houses. When Jupiter, in conjunction with Moon, is ascendant in Cancer, and when the day is advancing, Queen Kausalya gave birth to a son named Rama. A complete birth chart. Is it a realistic birth chart? Yes. If you are an astrologer, you can calculate the time instant corresponding to this birth chart. Today, computers are available, computer programs are available, where you can feed this chart and find out when this happened, when the event took place. At Ayodhya, which is a particular, the birth chart is always referred to as spot on the earth. It is referred to the Ayodhya. The date comes to be January 10th, 5114 BC, 12:30 p.m. And this is followed by the birth of Bharata, which is 14 hours later. And then there are several other instances which Valmiki refers to the happening in the sky, the constellations, and they are compiled in a book by Dr. Hari on historical Ramayana. This book was published by the Art of Living Foundation. He gives 10 different charts and 10 different dates corresponding to that, which fits exactly for the 39 years of Sri Rama. The birth was in 5114, and he goes to the forest at the age of 25. Dasharatha fixes a date of coronation on January 4th, 5089. Compute this, it is 25 years. And then in Janasthana is where Shurpanaki incident happened. And after the incident, there was a war between Khara, Dushana and Trishira against Sri Rama. Sri Rama killed all of them. And during that time, Khara, riding a chariot, surrounded by his ministers and other warriors, is compared to the Mars in the sky. The planet Mars. Mars is the planet of war. So Valmiki describes it very poetically. And if you accept it as a chart, as a constellation, it comes to be 5077, October 7th. Then subsequently, Vali's death at Kishkindha. Hanuman leaps to Lanka on September 12th, 5076. He returns 2 days later. All these are described. And even Hanuman's vision of the horizon is described. And that description can be recreated in the computer today. But that description of the horizon is more elaborate and more expansive than what could be perceived from the ground level. Hanuman is flying in the air at a particular height. Therefore, his vision of the horizon is larger, and that description is given by Valmiki, and it is accurate. It corresponds to these dates: September 12th, 5076, September 14th, 5076. Subsequently, the Vanara army leaves Kishkindha. A date was decided, an auspicious date was decided, and the constellation is described. It is September 20th. Vanara army reaches Lanka on October 12th. Incidentally, I mean, it is very difficult to swallow, but yet the dates match. It is very difficult to swallow that the Setu was constructed, Valmiki says, in 5 days. And Valmiki gives a description saying that the Setu, the length and the width is 1:10. And the length is 35, you see Ramasetu today, 35 kilometers. And the width is 3.5 kilometers. It is a flat topped Setu it is, where you can move an army. And below the boulders are flat topped, but below that are the irregular shape boulders. Below that are the wooden planks. All these descriptions are given, and please take a look at this book, Historical Ramayana. There are also YouTube videos on this. The point I am trying to say is Valmiki's description, I mean, is supported by a number system, or number system was available for him to describe. This is around 5000 BC. It is not 500 AD, 5000 BC. Another book, a Buddhist text by name Lalita Vistara Sutra. It describes the life of Gautama, it is Gautama Buddha, as starting from his birth. It narrates that, and as he grew as a prince, he was a polymath, that is, he was a master of several fields. And as he was growing as a prince, there was an examination conducted for the prince in the open court in front of the public, in front of the king, in front of the public. A mathematician by name Arjuna examines Siddhartha's skill in mathematics. And the description says, Siddhartha lists the powers of 10 starting from Koti to Tallakshana. Tallakshana is 10 to the power of 53. This number did not figure in the earlier list that we gave. From 10 to the power of 7 to 10 to the power of 53, he gave the names for that. And then taking it to the next level, he gets eventually to 10 to the power of 421. Enormously large number, extremely large number. Lalita Vistara also refers to an extremely small unit known as Paramanu Raja, which is equal to 10 to the power of -7 of an Angula Parva. Angula means finger. A finger length is a measure. So Angula Parva. So 10 to the power of -7 of that Angula Parva was called Paramanu Raja. What does this mean? It means the number system was versatile. It could represent huge numbers. It could represent small numbers. That is the meaning of the tribute given by Einstein as well as Laplace. Now, this number system originated in India, yes, but when is not exactly known, but it is certainly not in 500 AD or 300 AD Bakshali script. It is much, much earlier. It is, has a reference in the Vedas. It has a reference in the Ramayana. This moved westwards sometime during the 8th century AD. The script uses the number system 0, 1, 2, 3, what we call as the Indo-Arabic numerals, which we routinely use. We have already used it in this text, or this number 29 that is here. It is the Indo-Arabic script, we say. It is not Indo-Arabic script, it is Indian script. Arabia learned about it only in the 8th century AD. This is how it went. It went through a mathematician by name Al-Khwarizmi. The brilliant work of the Indian mathematicians was transmitted to the Islamic and Arabic mathematicians. This is Western historians writing. Persian scholar Al-Khwarizmi, Abu Abdullah ibn Musa Al-Khwarizmi, living around 800 AD. wrote on the Hindu art of reckoning, which describes the Indian place value system of numerals based on 1, 2, 3 up to 9 and then 0. This work was the first in what is now Iraq to use 0 as a placeholder in positional base notation around 800 AD. See, this Al-Khwarizmi, today we use the word algorithm. In computer science, we often use this algorithm. Algorithm is a tribute to Al-Khwarizmi. He was the first Persian scholar to learn about the Indian numerals and number system. Al-Biruni was an Iranian scholar who accompanied Muhammad Ghazni during his campaign in India. That is around 1000 AD. Look what Al-Biruni writes. What we, the Arabs, use for numerals is a selection of the best and most regular figures in India. This is Al-Biruni. The most regular figures which Al-Biruni refers to are the Nagari numerals, which had by his time been transmitted to the Arab world. So the numerals, the symbols originated in India only. The concept of 0 originated in India and traveled westwards during the 9th century AD. That is Al-Khwarizmi, yes. Reached Italy around the 10th century AD. And it was transformed, the name transformed. Originally, it was called Shunya in Sanskrit, also known as Shubra in Sanskrit, which became Sifra or Sifir in Arabic, became Zifr or Sifra in Latin, Zifiro in Italian, that is modern Italian, then zero or cipher in English. The earliest text recording this, the European text that recording this number system, its name is Codex Vigilanus. This is a Latin name. The text belongs to 976 AD or thereabout. It is available even today in a museum near Madrid. What does it say? It says, so with the computing symbols, we must realize that ancient Hindus had the most penetrating intellect and other nations way behind them in the art of computing, in geometry, and in other free sciences. Not merely computing, geometry, and other free sciences. And this is evident from the 9 symbols with which they represented every rank of numbers at every level. He says 9 symbols, he has ignored 0, but 0 is extremely relevant and useful, without which you don't have a number system there. So this is the earliest record available in Europe, 976 AD. So 800, 850, that period it went to Arabia. From there it traveled to Europe and it reached Europe, this is confirmed, around 976 AD, which means around 1000 AD. By another 2 centuries later, 1202 AD, there is a mathematician by name Fibonacci. Fibonacci is a reputed, well-known name in mathematics. We use Fibonacci numbers, Fibonacci sequence, and it is Fibonacci who wrote about the number system around 1202 AD. And he claimed that it is he who started this number system in Europe. Look what he says. There, following my introduction, look at it, my introduction, as a consequence of marvelous instruction in the art which he had, to the 9 digits of the Hindus, the knowledge of the art very much appealed to me before all others. Almost everything which I have introduced, I have displayed with exact proof, in order that those further seeking this knowledge with its preeminent method might be instructed, and further, in order that the Latin people might not be discovered to be without it, as they have been up to now. The 9 Indian figures are 9, 8, 7 up to 1. With these 9 figures and with the sign 0, any number may be written. That is 1200 AD in Europe. Let us refer to the scientific revolution. I have written 2 sets of names here. The top one is the Indian names, mathematicians. Bodhayan Acharya, he belonged to a period, he belonged to the Vedic period, you can say. I would put it as earlier to 2000 BC, because the Vedic period is rated as earlier to 2000 BC because the Saraswati river started drying up around 2000 BC, and the Vedic period is certainly earlier to that. In that sense, I am referring to Bodhayan Acharya as earlier to 2000 BC. Aryabhata is more clearly identified 476 AD to 550 AD. His most illustrious work, Aryabhatiya, was written in 505 AD. Varahamihira, he was a great scholar, a polymath, that he knew several fields. He wrote what is known as the Brihat Samhita, which contains 106 chapters on a variety of things. He was an encyclopedia of his time. Varahamihira. Bhaskaracharya second. See, the Aryabhata and Bhaskara the second, are 2 of the greatest mathematicians perhaps the world has seen. Bhaskara second. Madhavacharya belongs to Kerala, and his period is 1340 to 1425 AD. Now look at these names in the lower part of this file, where Nicholas Copernicus, Kepler, Galileo, Newton, and James Gregory. The time frame of these people is 1543 onwards down to 1675. These names are the leaders of the scientific revolution in Europe. What we call as the scientific revolution, it is supposed to have begun in 1543 when Copernicus presented his heliocentric model for the first time. And subsequently, of course, Kepler, Galileo, and Newton contributed significantly to the astronomy and algebra and calculus and other things. And this was a great, rich period in Europe. It is called the Age of Reason. But you compare this with the Indian mathematicians and their time frame, it is much earlier to this time frame. The time periods don't overlap. It is true that there was no great activity in India during the time period when Europe was very active. It is also true that Europe was not active when India was active. It is important to note this difference. There are historical reasons why India was not active during this period. India was overrun by invasions, ruled by foreigners, and it is not the time for creativity. None of these things flourished as it had flourished earlier. The art, architecture, literature, none of these things flourished as it flourished earlier. So there was no Kalidasa during this time, yes. Whereas Shakespeare was 1509 or so. So the periods are not overlapping. So creativity is not the monopoly of either Europe nor of India. It is universal, but India had achieved much during an earlier period, not during the recent 400-500 years. Let us look at that period. I'm looking at Aryabhatta. Aryabhatta is certainly one of the finest mathematicians the world has seen. In the Western world, they identify three major mathematicians. They can count them as greatest mathematicians. One was Gauss, another was Newton, another was I'll come back to that. Yeah. However, in India, there were three greatest mathematicians. If we count, it will be Bhaskara, Aryabhatta, Bhaskara, and Ramanujam. Let us look at what Aryabhatta said. Yeah. He worked on several fields: astronomy, geometry, algebra, and calculus. There is a text called Surya Siddhanta, as well as Aryabhatiya. They refer to the Indian time frame, Kala, the Kala Ganana of India, which refers to enormously large numbers. The period of Yuga, Manvantara, the Kalpa, all these things are enormously large numbers, millions, billions of years they count, and you need a number system to talk about the time frame of India. And India had developed a large number system, which can handle very extremely large numbers. And it is a common place for us to make sankalpa during Sandhya Vandana. Dvitiya Parardhe, Shvetavaraha Kalpe, Vaivaswata Manvantare, Kali Yuge. So if you look at the time frame of this, it is enormously large. I have put some numbers here. And the Indian history refers to, the historiography refers to a very large time scale. This is Indian historiography. I have tried to put it in a file where I would say the recent history begins, recent or even ancient history begins with Alexander's invasion around 326 BC. And if you count starting from 0 BC, if you go back, the time of Siddhartha, that is Buddha, according to the Indian records, it is 1781. At the time of Kali Yuga Arambha, that is the beginning of the Kali Yuga, which is an astronomical event. Aryabhatta refers to it very clearly, and even Bhaskara refers to it. All the Indian astronomical calculations are referring to the beginning of the Kali Yuga. And the beginning of Kali Yuga starts with an astronomical event when all the planets in the sky are on a straight line. It is not an event like Vikrama Samvat or Shalivahana Shaka, which began with the coronation of a king, or even Yudhishthira Shake. It begins from the date of coronation. But the Kali Yuga Arambha refers to an astronomical event when all the planets are in a straight line on the sky. And this date comes to be 3102 BC, February 18, 2:30 AM. That is the event. That is the reference to our Kali Yuga. All Indian astronomical references are with respect to the Kali Yuga, unless there is something earlier to that, which is with the Surya Siddhanta and other things refer to it. it is said that the Surya Siddhanta refers, there are indications that they are referring to something like 1200 BC. Again, based on the astronomical event. The Mahabharata war is said to be earlier to the Kali Yuga Arambha by 36 years. It is 3139 BC. And Ramayana is earlier to that. It is Rama's birth is dated as 5114 BC. There are other opinions on this. Some people refer it to as something like 7000 BC. Okay, this is Indian historiography. But when the Europeans came, they had another fixation, because the European history believed in the biblical reference. The Bible makes a reference for several things. See, this is the biblical statement. You see, Adam was the first patriarch, then Seth, Enosh, Canaan, etc. They'll come right up to Noah. At the time of Noah, there was a great deluge. This is what the Bible says. And Noah collected all kinds of samples from the earth, ported it into a ship, and he rode the ship. And when the deluge lifted the ship, he survived. And the deluge lasted for some 40 days or so. And then the waters settled down. He again started the creation of his lineage after the great deluge, the flood. This flood is said to be 2048 BC. And some people calculated the lifetime of these patriarchs. Each one of them lived a very long time. For example, Adam lived 930 years according to the Bible. And the various people, you will see 800 years, 900 years, etc. And the son of Adam was born when Adam was 130 years old. Seth, the next patriarch, was born when Adam was 130 years old. And Seth got a son and he was 105 years old. So they collected all these numbers put together, and they said the total time of flood from the beginning of Adam, that is the beginning of creation, to the time of flood is 1556 years had lapsed. Considering this, they calculated the period of creation as 1556 years prior to the great deluge, which was in 2448. This may be historical, 2448, but this was the projected date. And somebody in Europe said the earth was created in 4004 BC. And most of the European historians accepted this during the 18th century. Max Muller is on record saying that the biblical reference to the history is simply historical. I accept it as historical. So they believed that the whole creation was started in 4004 BC. Based on that, they wrote the Indian history, and they wrote that all these Vedas were written after the Aryans came to India. When did Aryans come? They came around 1500 BC. Why 1500 BC? Because the deluge lasted, deluge occurred in 2448, and after 40 days the waters went down, and after that they gave 1,000 years for the Aryans to settle down, and then they rode their horses and came to India around 1500 BC. Based on this fixation, they wrote the Indian history. They found that the Indian historiography, Indian time frame was too large, too exaggerated. So if you say the Kali Yuga Arambha started in 3102 BC, that should come somewhere here. Somewhere here. And if you say the Ramayana is earlier, it should come somewhere here. This the European mind was unable to accept. So what they did is they compressed the whole time frame to fit their notion of the creation of Earth, their creation of the human history. And based on that, they rated the Ramayana as 800 BC, Mahabharata as 600 BC, Buddha as 563 to 483 BC. All these are compressed scales. Compared to this, you see Siddhartha's birth, according to the Indian sources, is 1781 BC. But they brought it and put it somewhere here, 543 BC, Buddha's period. And the Vedas and other things, they put it somewhere here. So this error in our history is something which we'll have to examine and rewrite. Okay. Yeah. In the year 1650, Archbishop James Ussher of Armagh, a noted Bible scholar, declared that the earth was created in 404 BC, and this birth certificate was added as a marginal note to the book of Genesis. Genesis is one of the Bibles, one of the books of Bible, Old Testament. In the authorized version of the Bible, where it remained until Victorian times and survives today in some publications. Now his contemporary, they refer to it. It is concluded that this is the age of the earth in 1650 in Europe. His contemporary, Archbishop John Lightfoot, Master of St. Catherine College and Vice Chancellor of Cambridge University, added an amazing precision to compute that the earth was created on October 23rd, 4004 BC at 9 o'clock in the morning. Even the most sophisticated present-day methods to date the past can never hope to be that precise. But Indian astronomy refers to the period earlier to that, and there is no need to be apologetic about it. That's my point. Now, Aryabhatta refers in the Aryabhatiya. Aryabhatiya is a text of about 108 verses, divided into 3 sections. And Aryabhatta says his own birth, Mama Janmano Tita. He is talking about his own birth as when 60 times 60 years and 3/4 yuga had elapsed. 23 years had been passed since my birth. Referring back to the beginning of the yuga, 3102 BC, it is calculated as 476 AD. Aryabhatta knew that the earth was round. Earth is round. Bhugolaha sarvato vrittaha. This is part of Aryabhatiya. In the Golapada, 6th shloka, and rotates on its axis. And so also are the other planets, such as the Moon, Saturn, Jupiter, Mars are round and display axial and orbital rotations. Notice that this is in 505 AD. And the heliocentric model of Copernicus was presented to the world in 1543 AD. But Aryabhatta knew that the earth is round, stated it as such in his Aryabhatiya a full 1,000 years earlier. By the time Moon completes one orbit around the Earth makes 27.396469357 revolutions on its own axis. This is Aryabhatiya. An extremely accurate calculations. The correct figure in 500 AD, because this time slowly keeps changing. So if you go back to 500 AD and compute what was the correct time of a moon completes one orbit around the Earth, it comes out to be 27.39646,514. This is the modern calculation. The error in Aryabhata's computation was less than 0.365 seconds for 27 days. How did he calculate it? I do not know. But he said it with such accuracy in a very well documented text. Indicates how great a mathematician he was. So this is where the reference comes, Bhugolaha Sarvato Vrittaha. The globe of the Earth stands in space at the center of the circular frame of asterisks, surrounded by the orbits of planets. It is made up of water, earth, fire, and air, and is circular in all sides. That's the meaning of this statement. This is Aryabhatiya calculation. He's talking about a Yuga period, an enormously large period. He's talking about 432,000 years. 432,000 years. That is one Yuga. And he has given the calculation, or his calculation of all these planets of the solar system, how many revolutions they will do, how many sidereal periods revolutions they will do around the sun. All these things have been computed and given in Aryabhatiya. What is sidereal period? Sidereal period means with reference to a fixed star. From the point of solar system, it's a fixed star. And the planet is going round the sun. What is shown is this is the sun and this is a planet going round, usually elliptical path, and the sun will be at the, not the exact center, but at the focal point of the path. And when the planet returns to the same spot with reference to a fixed star, that is called a sidereal period. And Aryabhata computed this. Can he do this without understanding the heliocentric system? Look at the errors he committed with regard to the sun. His error is 3.34 minutes in a year. This is 365 days for a year. And sidereal, okay. This is Aryabhata's calculation. This is the modern calculation. The error is 3.34 minutes per year. And with regard to moon, it is 864 seconds. The error is so small. With regard to Mars, it is 28.86 minutes, etc. He wrote about every planet in the solar system. Aryabhata stated that the Earth rotates about its axis and the stars are fixed in space. The period of one sidereal rotation of Earth, according to Aryabhata, is 23 hours, 56 minutes, 4.1 seconds. The corresponding modern value is 23 hours, 56 minutes, 4.091 seconds. Look at the error. Fraction of a second for the full day, 24 hours. Aryabhata's value for the length of the year is 365 days, 6 hours, 12 minutes, 30 seconds. The correct figure is 365 days, 6 hours, 9 minutes, 10 seconds. Error is 3 minutes 20.4 seconds for a year. Aryabhata clearly states the manner in which eclipses occur. The moon covers the sun, the great shadow of the earth covers the moon. See, it is a clear, precise statement how the eclipses occur. And the Panchanga, our Panchanga reference even today, uses Aryabhatiya mathematics to compute the starting and ending of the eclipses. And they compute it correct to seconds. When does the eclipse begin, when it will end, all these things are computed in the Panchanga and documented and printed. And it happens exactly at the same interval, correct to the second. Aryabhatiya worked on trigonometry, he worked on series, infinite series, finite series, I mean the squares and the cubes. Arithmetic progression, yes, 1, 2, 3, 4, up to n is n into n plus 1 by 2. So this is known. But then 1 square plus 2 square plus 3 square up to n square, he has given the formula. This is Aryabhatiya Ganita Pada. And 1 cube, 2 cube, 3 cube, he has given the answer to that. His definitions of sine, cosine, versine, and inverse sine influenced the birth of trigonometry. He was also the first to specify sine and versine tables in 3.75 degree interval from 0 to 90 degree to an accuracy of 4 decimal places. Aryabhatiya gives us the formula for the area of triangle. The half BH is the area of triangle, half of base into height. He did not give it in the form of a formal modern formula, but he gave it in the form of a formula expressed in a verse. He says, Tribhujasya phala shariram samadala koti bhujarda samvargaha. The area of the triangle is the product of half of any side and the perpendicular from the opposite vertex. Aryabhatiya gives us the area of a circle. Half the circumference multiplied by half the diameter gives the area of a circle. This is the method in which it is being taught in elementary schools, how to compute the area of a circle. Aryabhata was intrigued, like many other mathematicians, about the value of pi. What we call as a pi happens to be the ratio between the circumference and the diameter of a circle, any circle. It's a constant. And this ratio is not a whole number. It is not a rational number. It is an irrational number. Therefore, mathematicians were always intrigued, what could be the real value of pi? And somebody wrote 2000 digits after the decimal point, 2000 digits they computed, but yet it did not stop. It did not end. Aryabhata gives a formula for calculating that. Archimedes also gave a formula, but then he gave a formula something like this. It is something between 223 by 71 and 22 by 7. This number 22 by 7 is often used in elementary schools to calculate the value of pi, to calculate the area of the circle. But Archimedes did not say it is 22 by 7. He said it is between 223 by 71 and 22.7. So the average value comes to be 3.1418. But the correct value is 3.141592653589, etc. and Aryabhata gives the value. Look at this statement. Chaturadhikam shatam ashtagunam dvashashtistatha sahasranam ayutadvaya vishkambhasya asanno vritta parinaha. What does this mean? Chaturadhikam shatam, 100 plus 4. Ashtagunam, multiply by 8. Dvashashtisthata sahasranam. Dvashashti is 62. 62,000 you add to this. And ayutadvaya, ayuta means 10,000. Ayutadvaya means 20,000. You divide it by 20,000, you will get a number. And that number is 3.1416. Aryabhata says that the value of pi is approximately equal to this. See the word asanno. Asanno means it is close to. He doesn't say it is the value, but he says it is close. Having given this formula, you compare it with the real value of pi, 3.1416 it is here, but the correct value is 3.14159. It is correct to the third decimal place. It is incorrect to the fourth decimal place, but Aryabhata recorded it as such. That is the perspicacity of this great mathematician. So I stop it here today and will continue next time with Bhaskara. Yeah. If you have any
Thank you, sir. So now the session opens for question and answer. First question is from Nagi. Anyone else who has questions, please use raise hand option in Zoom and we'll go in that order. The first question from Nagi. Yes, please.
Namaste, sir.
Namaste.
Yeah, sir, my question was, if you go to foil number 46, right?
Yes.
Where it says, yeah, here it says Yuga period is around 432,000 years.
Yeah.
Okay, but if you then go back to foil number 39 or 38, where you have talked about the timeline. Yes, this only.
Yeah.
Okay, if you see Rama's birth is 5114, which was in Treta Yuga, and Mahabharata is said to be in Dwapar Yuga 3139 BC.
Yeah.
But Kali Yuga starts from 3102 BC. So the time differences between the yugas is pretty less here, which contradicts the definition of yuga length.
Yes. This is true. I do not know whether Ramayana really occurred at that time or in an earlier time frame. I do not know. I go by what is being presented as by Valmiki and the computation that is made to the astronomical references, which refers to 5114 BC, which implies that Ramayana occurred about 2000 years earlier to Mahabharata. From a historical perspective, this is not unreasonable. I cannot say it's unreasonable. I still see that there is a 2000 years gap. It doesn't tally with the Yuga concept that we have been saying.
Yes.
But I still see that the culture, the civilizational aspect of Indian society during Ramayana and that of Mahabharata are quite different. This difference would require a time frame. And that time frame as allocated here is about 2000 years. Is it or is it not? I do not know.
Okay.
But as for the rest, I agree with you that it doesn't fit into the Yuga concept. Yes.
Okay. Thank you, sir. That's all.
Okay. Any other question from anyone else?
Hello.
Namaste, sir.
I am Yogesh Thakkar here, sir.
Yes, sir.
Thanks a lot, Subbanna ji, for such an explicit and very highly researchful lecture on the Indian numbers and all that.
Yeah, thank you.
Can I have the recording of this?
Yeah, it will be. It is being recorded, and you can get it. Yes.
So where can I, to whom should I contact? I am Yogesh Thakkar. I have been invited by Prathamesh.
Sir, you join our group, and it will be given in the group. And we also have a website. It will be loaded upon the website, and it will be available.
So whom should I contact for the joining the group?
Sir, can you type your phone number on the chat window? Is it possible? On Zoom chat?
Okay.
And then we'll note it down. Yogeshwar, right? Yes.
Thank you, sir.
Sure. Yeah. Any other comment?
Sir, namaskara, sir. SM Kulkarni. Sir, this Noah's story you said.
Yes.
He took. It sounds similar to what happened in Matsyavatara. We have that. Say during Matsyavatara, all these 7 sages have been. They were taken, and then the creation starts with 7 saints, and that's what we have. All these Gotras and all those. They sound similar.
Yeah.
What is your perspective about this comparison?
Yeah. They sound similar. There are many stories of our Puranas you can see the shadow of that the world over.
Yes.
There are many things like that. So more than that, I cannot comment. Shadows of these things here as well as there. In the Greek mythology also you see certain things which are there in our Puranas.
Yes.
So this Manu taking the specimens and going onto a ship.
Yeah.
That story is there in Indian mythology, Indian Puranas are there. So I do not know more than that. There are several things are common. For example, you see, this is just an example. See, this a week has 7 days. Monday, Sunday, Monday, Tuesday, Wednesday. These 7 days is a common aspect across the world.
Yeah.
And they are also known by the same names, referring to sun and the moon and the. Now, where it originated and how it originated, it might have originated with the civilization. This Vasara is a reference in the Vedas for sure. They are there.
Brahaspati Vasara we say for Thursday.
Vasara is, which we call as Vara in Kannada. It is Vasara in Sanskrit. So it is there in the Vedas. Now where exactly, but the whole world has accepted this.
Yes.
So the Indian influence across the world is there. If the Vedas are the most ancient texts in the world, you should say that it has been recorded in the Vedas and therefore it is of Indian origin.
Yes.
So likewise, many stories of our Puranas also are seen elsewhere in some form.
In some context, I read that initially these holidays, declaring holiday on Sunday, shutting down everything on Sunday. Actually, what was proposed during what you said, Nicaea, that Constantinople he did. That time it was proposed to be on Saturday because Jewish people, they do Sabbath on Saturday. But later it was nicely changed because he was a nature worshipper and sun god worshipper. It was changed to Sunday. The holiday was changed to Sunday. That's what I read somewhere in some context.
I think in the Bible there is a statement that God created the world in 6 days and on the 7th day he rested. And that day is called the day of Sabbath.
Yes.
It is there in the Bible under the 10 commandments.
Okay.
If you refer to the 10 commandments, the 4th commandment refers to this, the day of Sabbath. And God has rested on that day. Everybody should rest on that day. Nobody should work on that day. This is the commandment.
Okay.
Now that day, Sabbath day is Saturday for the Jews. Jews is the earliest Semitic religion is the Jewish religion.
Yes.
Later on, Christianity started 2000 years ago, 2020 years ago, let us say. And Christianity said the day of Sabbath will be Sunday.
Yes.
Why did they change it from Saturday to Sunday? But the rest of the story they accept. But why did they change it to Sunday? I do not know. And a few centuries later, Islam started, and Islam said the day of Sabbath or the day of rest will be Friday.
Friday.
So this is their internal arrangement, so we do not know much about it.
Thank you, sir. Thank you. Thank you.
Any other question?
Yeah.
Okay, fine. If there is no other question, we will end today's session with a Shanti mantra.
Yeah.
Yes.
Om.